One of our biggest concerns for astronaut health in space is radiation exposure.
The leading hypothesis is that the magnetic fields are blocking some portion of the solar wind from reaching the surface.
Unfortunately, the moon's patches of magnetic field are not robust enough to completely protect human explorers from the sun's radiation. But further study of lunar magnetic fields could lay the groundwork for future innovations.
Well, what if we got a strong enough magnetic field that perhaps we could produce artificially? That's a question that I think remains to be answered, but the crustal magnetic fields on the moon and lunar swirls kind of provide a hint in that direction that we might be able to learn something about.
NASA's space radiation specialists are testing different ways to do this. One strategy they tested on the Orion spacecraft involves crew members barricading themselves with as much mass as possible in the center of the spacecraft.
Radiation is a problem, this is clear. Shielding, passive shielding can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea is to use a magnetic shielding, is to build magnetic fields.
Other possible techniques in development include vests that add mass and electrically charged surfaces that deflect particles.
If engineers can design a system that generates enough power, we might one day be able to create magnetic force fields around spaceships that direct radiation, just like Earth's magnetic field. Right now, though, we're still looking for the right solution.
It would just be a magnetic field. And that might actually be practical someday. All we would have to do is figure out how to generate the field. Then it would reach out into space and do the rest. More specifically, the team suggested putting a field-generating device about 1 million kilometers from Mars. The magnetic field would have to be a bit stronger than the Earth's, which would be hard on such a large scale. But it's something we could probably figure out how to do.
But we can try to build an external magnetic shield. The easiest would be to do that in space, an orbiting field generator placed between Mars and the Sun, like a giant space umbrella. The resources and energy needed to build this is insane, but hey, we just built an atmosphere, so why not?
The other big challenge we have is just radiation in space. There's a field of radiation out there, high energy ions, electrons, all kinds of charged particles, and they're just everywhere. And this is showing the magnetic protection that the Earth provides to these particles. So we're sitting here on Earth, and we have this protection system around us, and the particles can't get to us because, and then we're effectively shielded from that. So the problem is when we go out into deep space, these particles are everywhere, and there's a tremendous number of them, and we have they affect our electronics and they affect us. So one of the biggest problems we have is what's the effect on us as we travel to deep space, and how do we protect ourselves?
This is a human nucleus, so it's 10 microns approximately, and these two lines that you see here are two iron ions that you don't find in space. I'm sorry, that you find in space but not on Earth, except in Darmstadt at GSI where we have it, going through the cells and making damage to the DNA. So at the end, shall we go to Mars or not? Well, I think I was supposed to give ideas here. It looks like, radiation is a problem. This is clear. Shielding, passive shielding can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea is to use a magnetic shielding, is to build magnetic fields for the spacecrafts that can do what is done on Earth. So it's not really a new idea. It's the same idea that God had a few billions of years ago when he said, okay, I want to make life, but I created radiation already. What can I do now? Okay, maybe I can make a magnetic field, And you see, it's very effective in protecting the Earth and our life from space radiation. Thank you very much.